that I just need to close my windows here, and then we can start. So just for note takers, just okay. So now, okay. So we have the okay. Now, is someone in the Jabber room for your and note takers? Any volunteer to take notes? Mo, you are continuing your good work. Okay, and is there someone else who can take also? Okay, thank you, Rachel. So this is the payload working group, and today it's like we said, we're continuing this all the AVT order, so it will be followed by the XR block. I have the old Notewell, but you've seen the Notewell before, so for the next time I need to update my Notewell slide in the document.
Yeah, basically different to the prior policy.
Okay, so but you've seen you before in the previous session, the AVT, the agenda, the status update, the payload format for flexible FAC, VP9, TSVCIS Codec, Tetra audio codec, and we'll end my timer hopefully. Since the last meeting, we had the RFC 8331, which is the ancillary payload published, and we have in AD evaluation VC2H high quality in AD evaluation. It's a current document status. No other documents, because basically all the documents will be presented, because we have two documents which are working group documents and two documents that are individual draft. The current milestones for the two individual drafts. So we have not for the payload. Sorry, for the working group to submit the. FAQ, we would like to finish it as soon as possible. It's in the list of documents that's for RTC Web that is waiting, and is the one of very, very behind because because we needed a new working group last call. And there's the VP9 video codec. Hopefully it will be finished soon. Okay, so this is the chair presentation. Any questions, comments on the working group status? Okay, if we don't have none, then we'll go to the next presentation, which is the FAQ, which we just received. So I'm sorry, the FAQ is not yet uploaded. Can you upload them in the FAQ? And that's today Mo made it even I expected that most presentation will come last, but it really came last. Okay.
Okay, this is version 7 of the flexible FAQ working group document. Next slide, please.
Try to see if the clicker works. It doesn't work, so
You need to.
you need.
You need to put it on your USB.
I need to put it on my USB. Yeah. Okay, so then it will work. So we'll try that as long as I'm here. Yeah. So I'll first. So now I cannot even move it forward. Okay. Okay, so I'll change to the next slide. See if it works.
Okay, so we got a lot of comments from the working group last call. So thank you very much for everyone for the very thorough reviews. The changes, all the comments and the changes were all mostly editorial clarifications, but very important clarifications because the text could have been confusing for implementers, so it could have caused real issues. but notably that there's no real changes in any of the normative parts of the spec, no changes in the packet formats, no changes in the operations that are done on either encoding or decoding sides, but a significant amount of churn in the text itself. So when you diff, and here I'm noting diffs from 07 to 05 because there were actually two changes, two versions of since the last IETF. And when you do that diff, it's pretty big. So don't let that scare you into thinking that we've made a lot of substantive changes. Hopefully just a lot of things that are going to make it easier for implementers. Okay, so quick, next slide. So summary of what's changed. There's a lot of general nomenclature that was imported from RFC 6363 before, and it doesn't really gel well with the RTP-based mechanisms that we're describing here. So we basically just replaced all of the generic words, flow and symbol and things like that from 6363, which is not just RTP. It applies to a lot of other transports and application level protocols. So we replaced those with RTP-centric terms from taxonomy. Hopefully that'll make it clear for someone who's just in RTP land. And in the abstract, several people mentioned that they didn't realize that this allows multi-stream protection until pretty deep in the document. That should be up front. So we added in the abstract that a single FEC packet can actually protect multiple source RTP streams. And there was some lingering comments about extensibility to other FEC codes beyond XOR. That was from earlier versions of the draft where we were expecting extensibility to Reed Solomon and Raptor and other codes. That was rejected because of IPR clarity. So you can file IPR declarations on specific drafts and not sections of drafts. So all those extensibility features have been removed. So FlexFEC is not that flexible anymore. But there were some things lingering that still mentioned it. So we removed all those. And then the introduction was pretty long. It's several sections long, but it was confusing for some readers to understand the differences between the different schemes that were being outlined. And so we made separate sections that clearly show all the different schemes, the 1D non-interleaved or row FEC, the 1D interleaved column FEC, and the combination of 2D row and column FEC schemes. Hopefully that's clear to readers now and implementers won't be confused. Next slide. And then Stephen asked for definitions, and we agreed that it was probably better to have all this up front in the document. So we added most notable definitions about row and column FEC and about what 2D FEC is. And then places where source block and FEC block were used, they were also used in 6363 undefined, so we made sure we defined them here. And the repair window, that's actually one of the parameters of the SDP negotiation, made clear what the repair window refers to, and then finally what XOR parity codes are. Next slide. Okay, and then in the packet formats, there was also some confusion here, so we wanted to clearly separate out what is an RTP header and what is a FEC header, and clearly separate out what are the source packet formats and what are the FEC repair packet formats. There was confusion around what does the RTP header of the source packet look like, and are there any restrictions? So we clarified that basically the full RTP packet can be recovered, except the version has to be version 2. That's the only restriction that this FEC scheme imposes. Everything else is standard RTP. You can protect any kind of RTP packet with extensions, with padding, with its own CSRC list and count. None of those have any restrictions or bindings to the FEC packets. Now, for the FEC packets RTP header, there was lack of clarity about what exactly all those fields mean in the FEC packets RTP headers. So we clarified that the CC and CSRC are explicitly used, and they bind to the source streams. So the CSRC of the FEC packets points to the SSRC of the source packets. So they're like the source packets, you can think of them as contributing sources of the FEC payload. And the extension and padding of the FEC packets are independent of the extension and padding of the source RTP packets. So if someone could have a reasonable header extension, like maybe the send time offset or something like that, they could attach those to the FEC packets independently of the source packets. The other main area of confusion was in the FEC header. So after the RTP header, inside of the FEC header, there's also variants of that FEC header, and it wasn't clear what all those variants were and when they applied and when they don't. So we broke that out clearly into 3 separate sections for the case where you have the retransmit bit 0 and the flexible bit 0. That means there's a mask, a bit mask that signals what the source packet numbers are. So you have the base sequence number plus a bit mask of all the higher sequence numbers that were used to generate this FEC packet. And then the second variant is when you have R equals 0, so not a retransmission, but F equals 1, meaning that rather than having a bit mask, there is a fixed pattern block. There's a fixed 2D block pattern for the source symbols. And there M and N give you the row and column dimensions of that block, and then you map the sequence numbers of the source packets based on that row and column number. And then the third format is a retransmission format. When R equals 1, F can be 0 or 1. And that's just an optimization to allow people to do retransmission without using the RETX 4588 format. And that's the majority of the changes. Next slide, I think that's it. So we need to restart the work group last call because the changes were pretty extensive. Even though they're editorial, there was a lot of them. And I think they really should help implementers not get confused by this.
Bernard Boba. So we have been involved in an implementation, and the thing that's actually turned out to be most confusing doesn't relate to most of the document at all. It relates to the kind of SDP negotiation that goes on in a number of weird scenarios, like people offering both like RTX and this stuff, and being real clear about what's mandatory to implement and not. Like my assumption in reading the document was you kind of have to support retransmission. So if you negotiate...
Can you clarify by retransmission, do you mean the old 4588 retransmission?
No, I mean the retransmission functionality in this document is mandatory.
Yes.
Well, that's kind of that's the confusion. That's where the confusion comes in. So I kind of, yeah, I mean, when you're offering it or answering it, the assumption is when you say you support this, that you're supporting the retransmission. And so like, as an example, when someone offers, like somebody might offer RTX in this, they don't know what the other side does, right? So you'd want to offer both of them. And then a little bit of the confusion is if somebody answers you, like, what do the answers mean? Like if it's only RTX, it means, okay, I only do 4588. I think that's clear. If they answer both, what does that mean exactly?
Are you asking for some guidance about prohibiting RETX if
well,
you're
something
using
of
this?
that nature,
This
or
takes
at
priority?
least like if you answer both, it means, like, do you look at the order that they put them in? Like, does that mean I put RTX first, so I like that better than FlexFec? So please don't send me retransmission from FlexFec. You know, those are the confusions.
Well, to answer your first question, all of the variants are mandatory. So maybe we should add some text to clarify that all 3 of the variants that I just previous slide, please.
Yeah,
All 3 of those are mandatory in the spec.
they're all mandatory to decode and interpret. Doesn't mean they're not all clearly all not mandatory to send.
Well, you're never mandated to send any FEC
Right.
packets.
So I mean, my inclination would be the standard operand semantic is if you list FlexFec before RTX in your codec list, it means you prefer it. If you list RTX first, it means you prefer that. And I think that's just, I would think that would be standard. Now, of course, the tricky thing is that, you know, the point of using FlexFec is that, you know, you don't need to go through some of the convolutions about, you know, binding retransmission sources to primary sources. So how do you negotiate that if you don't know in advance whether you need to do it? But that's a separate question, I guess.
Yeah. Yeah, and also, yeah, I guess the other thing, which is maybe just my own confusion, is just there are only 3 SDP parameters defined right now, and so I've had questions about whether those are the only, those are the only 3 you need to kind of define it or not, and whether there's other kind of non-negotiated settings that one would normally have in an implementation to change things. But
What do you mean by non-negotiated settings? Like what percent effect do you want or something like that?
right, but that's not an SDP negotiated thing. That would be just something set on the sender.
Yeah. No. How a sender decides how much effect to send is not covered by the draft. And that's largely based on RTCP feedback and implementation, decisions.
Right.
Yeah, I just off mic. I just said that might be something the W3C needs to talk about, and sadly, Harold has left.
Well, I'm the other chair. But
Oh, you're the other chair. All
I'm
right.
confused.
Okay, so
So from all that, I think for the notes, we can make one update to clearly spell out that all 3 of these variants, including the retransmission, are always mandatory to support receiving by anyone that implements this spec. Any interplay with old 4588, we can add a 1 or 2 sentence thing saying that regular SDP and RTP mechanisms still apply. M-line preference still applies. Things like that. That should be easy enough to add.
Okay, so to support it and receive, that's what you mean, all 3 of them.
Yeah.
Okay.
Ma-
Is that,
mandatory to support and receive, and guidance about sending, is up to implementation.
so,
Yeah, the receive stuff makes sense. I guess it's a little bit confusing because if I offer both, does the answer assume that I can, like he's going to come back with something, right? Say I offer RTX and FlexFec, and he comes back and says he wants to do FlexFec, and doesn't put in the RTX. Does that mean, but he would, can the answer always assume that it's mandatory for the sender to support retransmission as well? Because he's got to answer something. Because basically, does he have to put both? Like he'll put FlexFec and RTX because he doesn't know whether I'm going to send RTX or something, and then I'll take that, and basically if I want to do retransmission as a sender, I'll then do it.
Are you
if
asking?
I don't want to, I'll do the RTX instead.
Are you asking that if you throw something in your offer, are you always obligated to honor it, even if the answer removes it? No. If they remove the payload type in the answer, you're not obligated to keep that payload type in play anymore.
Sure. Maybe Jonathan.
brother, I mean, if you're talking about an RTX style mechanism, I mean, the other half of that is you also have to negotiate that you support the NAC RTCP feedback. So, but I think if you have both RTCP feedback, my expectation would be if you support both FlexFec and NAC RTCP feedback, then you're expected to do NAC. That is an implicit expectation, and maybe we need to make this more explicit somewhere that I expect to use the whole actual full NACing mechanism and whatnot. But
that was one of the updates that we made. We did mention that on-demand retransmission can be done using, for example, RTCP NAC.
right.
We didn't mandate that you have to use this retransmission format if you NAC. So if you want to use RTX instead,
Right.
you
and
could.
And remind me where, and I'm blanking now, which parameter, I mean, with 4588, did it have a parameter of what the window size was? And do we have that? RTX, do we have something equivalent for this?
Yes, it's one of the 3 SDP parameters.
Rod, you have as individual. Just for clarification, so if in the offer I can offer both RTX and this, and I don't know how I will receive them basically from the sender. It can send it in either as an RTX or inside the FEC as an RTX. So that should probably be clear.
I did not see any need to prohibit RETX. I think the goal for most people is to deprecate RETX based on this. So I would expect practical systems when they negotiate, if they negotiate both, then the answer could just drop RETX because it's redundant. But that's up to implementations.
Ronnie, but since if the receiver wants also is to support RTX, he cannot force it to be part as here in the signaling that RTX will be supported by the sender, because you said the sender it's an optional for him to send the RTX. So if he want to have RTX, then the only way to do it is only if he offers to receive RTX separately also. Unless you have something that will make in this case, the sender send RTX.
I agree with what you just said, Mo. The thing we want to be most clear about is what do you do in negotiation if you don't want to have any RTX? You just, both sides would rather do FlexFAC. I'm assuming they both just can put in flex.
Then the answer would remove the RTX payload type.
Right. So you would offer RTX. Well, say I'd rather do FlexFAC, but I can also do RTX because I already implemented it. Okay. I assume I'll put FlexFAC first and RTX second in my offer, and then the other side, if he prefers FlexFAC, will only give me FlexFAC, and then I can send and receive FlexFAC. Is that
right?
A reasonable thing? Okay.
Yep.
So, I mean, the other question is, what if you only want to do a forward error correction model and not a retransmission correction model, regardless of payload types? In that case, I would say you negotiate FlexFAC and do not negotiate NAC.
Okay. That's simple.
Mm-hmm.
Okay, so does anyone feel we need to add anything else in the document for this discussion, or just enough to so that we mandate all the variants, including retransmission?
So do you know what really was the outcome from that in terms of what they want to see in the document in terms of the or you want, I mean, or maybe you can ask another.
What I thought I heard was people want to negotiate, offer both RETX and FlexFAC, but answer with only FlexFAC in order to deprecate RETX if both are supported. But I don't know if we want to. We definitely don't want to make that a must. We definitely don't want to say that implementations have to do that. Maybe we could make it a should in the document that implementations.
Okay, so just for the
lower should.
Just for the procedure, we'll start the working group last call, and I would like you to make this as a comment on the working group last call, so it will be addressed, and we can finish it as part of the working group last call process.
That's probably the fastest way to do it.
Yeah, because it can be a working group last call comment. Okay.
Yeah.
Okay. Any other issues? Okay. Thank you. Now we are going, Jonathan.
All right, this is the VP9 payload format. It's version 5. Okay. So it's been a while since I actually talked about this here. So these are some changes I made last year, and thanks to Tim Terraberry for the review. There were some terminology changes because the old terminology was deeply confusing and used massively inconsistently in the document because it was confusing even for the authors. So we've standardized on, because this is doing spatial scalability, we've standardized on frame for one actual encoded frame of image and picture for, all the frames of a, all the set of frames, representing the same, image at different resolutions or what have you. And then for our patterns of the temporal scalability, we had called it a group of frames, but it's actually the things that were being grouped were actually pictures, but group of pictures means something else in video coding. So we called it a picture group instead. This is not the greatest terminology, and suggestions for something better would be welcome, but we couldn't think of anything. So, and there's a note in there saying no, a picture group is not the same thing as a group of pictures. This version of the draft also added some explanations of how to use VP9 for scalability, both in terms of like what flags you have to turn on and off for each frame, and also how you structure the use of the reference buffers to get both temporal and spatial scalability for 3 temporal, 3 spatial, using the 8 reference buffers.
Stefan Wenger, Jonathan, please make sure that, it would probably be a really good idea for the terminology to keep it aligned with what you plan to use in AV1. Yeah, or go back and use what everyone else is using, things like access unit, right, instead of super-frame.
Yeah, I'm certainly not using super-frame.
Huh?
Yeah, but it's not quite, the thing is, it's not quite the same thing as an access unit.
No, I know.
Yeah,
Anyway,
or a temporal unit, which is AV1. AV1 is
for every new video codec introducing new technology that's not even aligned with the video codec spec itself is in a payload format is kind of moderately confusing.
I agree, but they don't exactly have, because the problem is that at least here, we're the spatial scalability is invented by the payload format. It's not in the spec. AV1 has it more fundamentally, so I guess I'll try to coordinate with Alex to figure out what terminology he's using. And the other change in 04 was the LRR format is now aligned with the actual LRR draft, which is fast working with less call. All right, and then 5, thanks to Tim Terryberry for the review. This defined the behavior. The main change is to define the behavior for frames that have basically the frames with show frame equals false. Sometimes called alt-ref. Similarly used for the equivalent of B frames. It doesn't work quite the same way, I think, mostly for working around IPR reasons. But basically, these are pictures that are frames that are never meant to actually be displayed at the time they're encoded. They're usually displayed later with a very small show the reference buffer thing at the time it's meant to be decoded. So the thing we specify here is that these get their own picture ID. You can have a set of these in the same spatial scalability structure, and those get their own picture ID, even though in the VP9 container formats, they're the same super frame as the subsequent displayed frame, because there's this notion that you have to, every super frame has to result in a single image popping out. But for RTP payload format, that's not the semantic we wanted. We wanted those to be, listed separately so that you can do the scalability properly and the like. And this then makes the question, because these are never actually displayed, what their RTP timestamp should be is a little ambiguous. So I basically said, do something vaguely sensible, but it doesn't actually matter that much. So basically, in particular, because container formats, they'll be part of the same super frame, and timestamps are assigned to super frames. I say this can be, the timestamp may be the same as the subsequent displayed frame. So the open issues, the offer answer needs thought and review. Slice loss indication usage needs specification if anybody cares. I'm not sure anybody's still doing slice loss indication. And we need a whole lot of descriptive text for VP9 because right now the actual descriptions of the codec proper are basically missing. We also need a whole lot of editorial work because the document's kind of a mess. And also reviews from more people than just Tim would be nice. Thanks, Tim. Tim's reviews have been great, and more reviews from Tim would be great too. But this has been implemented. We're actually, this is actually shipping in Chrome without a flag. So it'd be good if the document describing what Chrome is doing actually, were published. So I'd love if anybody else would volunteer to review this.
Jonathan, if this has to do with VP9, maybe it's not people who are here who needs to
That's
review.
true, yeah.
So you have to ask them specifically.
Yeah, I could certainly, call out to that too. But but obviously we need, reviews from VP9 experts, but also from RTP payload experts.
Okay.
So, okay, I see a hand from Mo.
Okay. Mo
Mo is volunteering.
Okay. And so when are you expected to be ready for working with last call?
I mean, I could try to get it for the next cycle. I mean, again, it's somebody has to write this descriptive text, and I'd rather it not be me. At one point, Tim volunteered, but Tim has done a lot already, and I know he's got real work on his plate. So, okay. Tim says the draft is in much better shape, and it might be a lot easier now. And so, yeah, if Tim were able to contribute text for the descriptive things about VP9, that would be awesome. Or otherwise, I can, try to wake up my co-authors to get some of them to do it or something. But
They are co-authors, so they should put some work.
yeah, I know. That would be good.
Okay.
And so, other than that, like I said, any reviews, all reviews are welcome, and or anything. And so, because I would like to get this, like I said, this is in shipping. This is in, this is in, however many Chrome browsers are out there, which is quite a lot. So it'd be good if we actually documented how it should work.
Okay.
What do you plan to do about the normative reference for the VP9 spec, which is at the random Google Docs document right now?
That's, if you go to the VP9 webpage, that is Google's official specification of VP9, despite it being
version 0.6. Yeah.
Yes, version 0.6.
Okay.
Yes, that is the official specification of VP9 according to Google, and VP9 is a Google private specification. So that's, I mean, if Google publishes something better before then, I'll update it, but that's right now the official Google specification. So it goes.
Okay, thank you. The next one is the, this one's the here. Victor, let's see, Victor, how do you, okay, Victor, you can speak.
Yes. Hi, can you hear me over there?
Yes.
Okay, very good. Yep. Okay. First, thank you. The draft that we have submitted for the payload meeting is for a new speech codec that we have been involved in, which is the TSVCIS audio codec. If you can go to the next page, this is called the Tactical Secure Voice Cryptographic Interoperability Specification. The spec itself has a lot of non-voice related description in it, and the better document to look at to see what the speech coder does and how it's a variable data rate speech coder is from the Navy Research Lab, and that's a reference in the draft that we have provided to you. It's based on the MELP speech coder, which is the previous draft that we had been involved in providing and shepherding towards an RFC. And as such, it basically extends the information that's in MELP and replaces it with additional LSF parameters, line spectral frequency parameters. And that's packed. There's a certain number of them that you can use. You can actually use kind of a variable number of those. One of the properties that exists is if a gateway or a transmission path or a receiver doesn't have the ability to use all of the information, it could pass on fewer LSF octets or even strip them completely away. So the RTP payload format allows for that to be done. The proposed format that we have allows for the contents to be stripped or reduced in complexity as it's being transmitted or used by various devices or conferencing stations or conferencing devices and other endpoints. So we would like to have this next page, please. So this has been submitted last October. It's been reviewed a bit out of band. So far, there's no significant text changes. I have discussed it with a couple of entities, see if I can get them to publicly announce some support. It'll take a little bit of time for that to happen. We would like to promote it as an IET draft because that would help ensure that it's a MELP-E compatible RTP payload that gets used for this. So that's what we're asking for this group, is to have it adopted by the IETF, to promote it as a standards track.
Okay, so as you can see, this is an RTP payload for a voice codec. This is in scope with the charter of the working group to do RTP payloads. So I suggest we would like to ask if we should accept this as to have support for the TSVCIS Codec pay RTP payload as a work item as a milestone in the charter for the working group, and the other thing is to accept this document as the documents to fulfill this milestone. So, are there any objections to do this work?
No. Colin Perkins, no objections. Do it.
Okay. So after just to the notes, I will send a question to the list to check this, and then we can accept this as a milestone in a working group document.
One minor technical comment for the authors: the MIME type registration needs to specify rate as a mandatory parameter.
Okay, I'll check it. I didn't check on this one. I checked on the other one that we have, but this one I didn't check. But I'll check it also and verify and send comment also to the list.
The other one looks to be okay. That's a trivial thing.
Okay. Victor, did you get? You have to verify that the registration, the annual registration, that looks according to what is the standard format or template for doing this.
Okay, I will check it over. I thought that I was in that. I just followed what one with the help RFC earlier, but I will recheck what I got.
Okay. Thank you, Victor.
Mm-hmm.
Okay, no other comments on that? Okay, so we can now move to the next presentation, the last one for today for payload, and that's the Tetra. Andrea?
Good afternoon. I want to present a quite old codec to be standardized as RTP payload. It's about the Tetra codec. This is an algebraic codec, excited linear prediction type codec. It's NATO 4.6 kilobit per second, and encapsulated in RTP. It comes with 20 bytes payload on 30 millisecond packet size and 40 with 60 millisecond packet sizes. It's quite similar to the ones which are already specified by RFC 3551, so G.723.1, G.728, and so on. And I just tried a little bit to compare about computation complexity, which is the size of the balls, Morse values, and IP data rate. So one could ask, why should we strive to standardize a codec which comes with a worse MOS value with a higher computation complexity and the same bandwidth demand as G.723.1, and it is because Tetra is still heavily in use by public safety organizations, police, fire brigades, ambulance services, and the Tetra itself is there are a variety of interfaces. The air interface, mobile, the so-called direct mode, the trunk modes, the interface between the mobile and the base station is pretty well specified, while the control room is not specified. It's a proprietary interface of all the different vendors. Next slide, please. I'm working for a registered association, the EMEV, a German registered association, which takes care for exactly this control room interface, where we have the data infrastructure. We assume there is a gateway, either as an integrated part of the data infrastructure, or as a third-party vendor device. And this interface here is based on SIP RTP for voice communication, and it has a SOAP XML part for data and management interface as well. And here the data codec really matters because the data codec anyhow is in charge on the air interface, where it's the only standardized codec type to be used. And if we think about, there is an example with fire brigades in Berlin, for example, continuously using up to 800 data talk groups, where they permanently do voice recording for their legal evidences. And for them, it totally matters whether you have to deal with 60 megabit per second of quality of service IP bandwidth, or whether you can reduce it to smaller than 9 megabit per second. TETRA Critical Communications Association, a body instantiated by the ETSI, it was the former TETRA Critical Communications Association, is already working on the successor of TETRA, which will be 4G LTE based. It's called Mission Critical PTT application, SIP RTP based, and we expect that renewal cycles, or we know that renewal cycles of such infrastructure investments typically last very, very long. So we assume there will be a migration phase from TETRA to mission critical PTT, which will last at least till 2025 or maybe even longer. And for this period of time, it totally makes sense to have this TETRA codec standardized as RTP payload, as mission critical PTT is using SIP RTP for its voice communication. So I warmly invite you to do a review on the draft I have proposed, and ask for adopting this draft by the working group.
Okay, so again, this is an individual draft. I'm not sure if anybody else read it. I sent comment about it, and we'll have a revision also about the registration. So the question here is about, again, it's like the previous one. This is again an RTP payload. It's coming from a body in Germany, and it's in charter of our work. So we would like to get it as a milestone and adopt the document as a working group document. Since we currently have only 2 documents as working group documents, and hopefully we are going to finish, at least the FAQ is the highest priority, we don't have much burden on the working group, so we don't have problem with accepting 2 new payloads for our work. Yes, Mo?
Mozinati, can you clarify, is the TETRA codec in widespread use, or the TETRA codec over RTP is already in widespread use?
TETRA codec over RTP is not yet in widespread use. It's just as a draft in this registered association. We published a standard which just has informal character, but no normative meaning. And we want to spread it, of course. And we assume that due to mission critical PTT over LTE, it will become more of interest.
For the people that are using it without RTP, what are they using it over
It's
today?
circuit switched infrastructure. It's 64 transparent 64 K channels, where they are using 1/8 of it to transport one single audio channel.
Okay, got it. Thanks.
And I assume you also have some experimental use currently on IP, because I saw you have this point that you are already testing that implementation.
Yes. Yeah.
Okay. So any objection to accept this work?
Hi, Colin Puckins. So I read this draft. It's a little unusually formatted for a payload format, but technically it seems.
I sent him all the. I mean, I also noticed, and he's making some changes on it. So I sent the comments to the list. I don't know.
So I didn't read your comments. Technically, it seemed okay. My only technical comment would be that it should probably mention the circuit breaker as a congestion control.
In the congestion
mechanism,
control,
but,
okay.
It seemed technically reasonable. It's clearly in scope, so I don't see why we wouldn't accept it.
Okay, thank you. Okay, so I'll send to the list a question about accepting this work, and we look also the congestion, on the congestion. I said the comment on congestion, I didn't put, you're right, I didn't put the circuit breaker in that, so we'll look at that. Okay, any other? Okay, so thank you.
Thank you.
So this is the last presentation for payload. Any other issues that you want to say? Okay, if not,
Ben wants to start the working group last call on the FEC stuff as soon as possible.
on the fact, yeah, we said, I don't know, on fact, what I said, I will start the working group last call, and one of the comment we had here will be addressed as the working group last call comment. That's okay. That's in the notes already. Okay, so now we finish with payload, and the last section of the session today will be the XR block one. So first of all, the blue sheets for payload. Can you take them?
I'll take care of it.
You take it, okay. And now we are going